All right. Hey, everybody. Okay, so we are on day 26. So let's look at what we have to do. We're going to work on 11.3 worksheet 3 and the cumulative review worksheet number 6. Ooh, that's exciting. Now, remember a couple things. Cumulative review is old final exam questions, right? So we're going to pay close attention, and anything we need to look up, we want to make sure it's on our note sheets for the exam, right? Speaking of which, don't forget, you get the whole yellow packet. Mine's not yellow, but you get the whole yellow packet. Plus, you get the chapter 11 flow charts. Now, the chapter 11 flow charts you're going to work on this weekend, and they're very densely packed. So as you fill them out, make sure that you are doing a good job of writing everything that I write. I do not write stuff for my health. I wrote it for you because you need it. So keep that in mind as you do them. I'm just going to give you a little taste here. So write write it all, right? It's not for me, it's for you. You want to write everything. And I've lost one of my flow charts. I don't know where it is. I've lost one of the chapter 9 ones. It was here the other day. Chapter 10, chapter 11. Well, anyway. Oops, hold on, my camera's on the wrong screen. There it is. Okay, so just a little taste. That's how packed it is. And look how small I am writing, right? So that's that one. Here's the hypothesis test one. So you got to write really small because you got to fit it all in there. So be careful. Good. All right. And I can't find one of my confidence interval flow charts to save my life. Oh, here it is. Ah, it's panicking. There's my confidence interval flow chart. So you don't get to use chapter 9 and 10 flow charts. You only get to use the chapter 11 flow charts. Plus, you have 2 sheets of paper, front and back, that you can fill out with your own stuff. As I've told you guys before, one more time, usually people use the one from the midterm because they did such a good job with it. And then the back page of the hypothesis test one is blank, and students fill that out. Usually they find they only need one side of a sheet of paper because everything else they need is in these flow charts or the yellow packet. But if you want a full sheet of paper to write both sides on, you feel free. All right. Now, when is that exam? Well, it is 2 weeks away from today. 2 weeks from today. That's when it is. You got to get it done. So it is on Wednesday in class on Zoom, morning or evening, or it's in the testing lab Wednesday or Thursday. And I sent the email out and I sent the text out on Remind about telling me where you're taking it, filling out this little location survey because I got to get it all set up at the testing lab. Okay. Questions? Oh, and have I talked long enough that you could fill out your attendance survey? Hopefully. Okay, so let's look at 11.3 worksheet 3, shall we? Oh, my camera. Sorry, I did those videos this weekend and I like adjusted the camera for the videos and now everything's all wackadoo. So, oh well, we're gonna work on it. All right, so let's look at this. So 11.3 worksheet 3, which is on page 522 to start, right? 522. So let's see. I'm just debating here. Which ones do I want to do with you? I want to do something fully. Just out of curiosity, do you feel like you need more help with confidence intervals or with hypothesis tests? What do you think? I think I might reverse what I did before. No votes? You don't have a vote? You don't have an opinion? You guys are killing me. Which one's worse? Hypothesis tests or confidence intervals? Or are they both the same? No difference. All right. Come on, have an opinion. This is where you type in the chat. Tests, intervals, tests, intervals. Which one would you rather have me help you with more? See, thank you, Kendrick. Having an opinion. I appreciate that. So let's do this one. Let's do like a little bit. Okay. Oh, they're both the same. I disagree, Nolan. I think intervals are harder. I agree with Kendrick. Because tests follow a pattern, right? Is the pattern's really okay. All right, so let's look at number 1. So the concentration of benzene was measured in units of milligrams per liter, which is mg/L, for a simple random sample of 9 specimens of untreated wastewater produced at a gas field. The sample mean was 7.9 with a standard deviation of 1.9. That was group 1. And then 7 specimens of treated wastewater had an average benzene concentration of 4.1 with a standard deviation of 1.6. Oh boy. Okay, so they're giving us the information. It's not going to be in a data table, right? They're writing it in a big paragraph. So the first thing they're asking us for is to compute the SE of X1, X bar 1. So SE stands for what? What do those 2 letters mean to you? There you go, standard error. See, you guys are learning stuff. All right, so this is standard error. Now, since it's of X bar, there's a formula for that on page 166. I'm gonna put a little star next to it because it's not on the yellow packet and it's not in the flowcharts. That's a thing to look up and put on the note sheet maybe. All right, so grab your notes. So the SE of X bar 1 just means it's for group 1. So if you look, it says group 1, right? So this whole thing is group 1. Oh, that's a terrible underlining job I just did. That was a very wobbly underline. All right. So let me grab the notes so you guys can see page 166 real quick. All right. So standard error of the X bar is here. They're essentially equivalent formulas. It's just you don't know if the standard deviation that was given is a sigma or an S depending on the situation. In our case, it's an S because it's a sample. So sample population, tomato, tomato. It works either way. So it's S over the square root of N. But for us, we want the S from group 1. So we'll put a little 1 after it over the square root of N1. Okay. So what's the S for group 1? Mm-hmm. 1.9, right? It's the standard deviation for group 1, which is 1.9. Now the N for group 9, oh, this is a little harder. N is the sample size, right?
7.9.
No, that's group 1, so that's good, but that's a mean, right? Because it says the mean.
Oh, yeah.
Oh, yeah. So what was the sample size? Yeah, Owen's got it. I was sneaky and I didn't write it with a number. I wrote it with a word. Hello, N1. Old buddy, old pal. It's right there. See it? So N1 is there. So it's 9. Right? It's not 7. 7 is actually group 2. So, all right, somebody grab Desmos and find that real quick. I'm going to underline these other ones. So group 2 this is N2. That's the one for group 2 because that's the beginning of another sentence, right? It's after the period. So 7 specimens had an average, right? So you had an average of 4.1. So that's X bar for group 2 with a standard deviation of 1.6. So that's the S for group 2. See how this works? All right, what do we get? I don't have the answer, so I need you guys to tell me what it is. I didn't do this one before. Oh, is it 0.8757? Hold on, I'm looking up my answers. I don't think
I
these are.
got 0.63333.
Yeah, so did I.
33333.
Oh, wait, there is no StatCrunch path for this, honey. No. Okay, that's a different thing. You have to do standard error specifically as stated. That's a different standard error. That's something else. So I see what you're doing. Don't do that. All right, so you have to do this. So it's 1.9 divided by the square root of 3. Oh, 9. Square root of 9. Square root of 9 is 3. Sorry, that was what I was thinking in my head. So it's 0.633333. But I like it. Okay, so everybody notice. So that's okay, what Allie's talking about. That was a clever idea. It's just not going to work. So here, hold on. If I go to StatCrunch, I've got to sign in real quick. So if I go to StatCrunch, now this is actually going to help us with the next part anyway. So when we want to figure out what we're doing down here, these are two separate groups, right? These were two separate samples, and we're talking about the averages. So it's stat, t-stat, two sample. Right? It's not a paired thing. They're separate groups. So it's stat, t-stat. So let's do that because we're going to have to do it anyway. Stat, t-stat, two sample with summary, right? We don't have data tables on this one. And the mean, okay, so the mean for group 1, what was the mean for group 1? This is B, by the way. We're doing B. So yep. Okay. So 7.9, 7.9. All right, now the standard deviation was, yep, there you go, 1.9. Whoops, 1.9, then 9. Right, that's what Allie just texted. All right, now the mean for group 2, (4.1), there you go, 1.6, then 7. And then you click confidence interval because we're doing a confidence interval for part B. And then we're doing, let's see, what confidence? 90? All right, so make that a 90. I'm going to do a confidence interval plot too. You don't have to, but okay, so this standard error is not the standard error that I'm asking for in part A. This is a complicated joint standard error. It's actually the standard error of the differences, which is its own thing. It's not of any one X1 or X2. It's its own deal. So this is not what part A is asking for. Is that making sense? So don't use that for part A. That is not it. But you can use this piece for part B because the lower and the upper is the confidence interval that we were looking for. So the lower number is 2 point, many decimal places, 2.2566 and then 5.3434. Good. I had never even thought of doing that. So thank you. Because I didn't realize that was a thing that, I mean, I know it's there, but I know it's different. So I know it's not what I was asking for. All right, everybody good? Stat, t-stat, two sample with summary. Now, if we want to take a thing for the point estimate, so the point estimate for the differences is just x bar 1 minus x bar 2, which we know what those are. As a matter of fact, here, let's look. It's right here, right? Because that's the differences, right? The difference is 3.8, right? If you take, what was it, 7.9, 7.9, take away 4.1, right? It's x bar 1 minus x bar 2. Now you can do the lower upper thing if you want, right? But it's kind of not necessary. So we learn that this is this. So that's 7.9 take away 4.1, which is 3.8. Oh, technically it's milligrams. I forgot. Milligrams per liter. Sorry about that. There's the units on that one. And this is milligrams per liter. Not that I care that much, but now if you want to do the lower plus upper thing, you can, but you're going to end up in the same answer. You're going to end up with 3.8. Now, as for the margin of error, there's a couple ways to do that, but our easiest way generally, if we have the interval, is to do the upper minus the lower divided by 2, right? That's the error. So the upper number is 5.3434 minus 2.2566. Close parentheses, divide by 2. All right, somebody find that, and I'm going to start writing the. Thank you. Again, that's technically milligrams per liter, but I wouldn't mark you wrong if you didn't have the units there. It's not the end of the world. I didn't ask for units, so it's fine. So the average true difference in the average benzene concentration levels is between our lower number, which was 2.2566 milligrams per liter, and 5.3434 milligrams per liter. Boom. Okay, so we have the percent, we have the lower here, the upper here, right? This is lower, this is upper. And then the hardest bit is this difference in the average, blah, 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 right? That's the context. So, and that's the hardest bit. I will say, I'm going to take this back. I don't care about the milligrams per liter up here. I mean, technically it's true, but I just don't care. I'm much more concerned about it when we get to the interpretation part. The interpretation part is the part that should ask for units and does. So I'm okay if you just say 3.8 and 1.5434. That's fine. Everybody good? Now, I want you to notice the difference here. So in the last section, when everything was paired, the way we wrote this was the true mean difference, right? Because it was the mean of the differences, because we would find the difference as a separate row and thing. This one, they're separate groups. So it's the difference in the averages for the groups. It's the difference in the means, right? So you say it differently for the two sections, 11.2 and 11.3. Oh, and this was all on page 189, which is your chapter 9 flow chart. It'll actually also be on page, hold on. What is the chapter 11 flow chart for confidence? 227. So it's also on 227 when you do that one. It's on there. This pen is dying. Oh, I gotta throw this pen out. Right, there we go. It's pitched. And I have another one. I just can't figure out where it is. All right. So for the last one, which one are we gonna circle? For the record, my husband was not coughing all morning. He comes into the room while I'm teaching and coughs the whole morning. I'm teasing you, honey. He was in the other room, all quiet as a mouse, like not coughing. Nope. Terrible. He's saying, call the police, call the police. Terrible. Yeah, okay. So yeah, we're gonna circle yes because it's not contained. Yeah. So see how 0 is not between these two. I was looking for my other navy pen, but I can't find it. Know what I've done with it. Oh, here it is. It was fell under my keyboard. So if you think about the number line, you've got 2.2566 over here. You've got 5.3434 over here. 0, these are both positive numbers. So 0 is over here. 0 is not contained in that interval, right? So it's either this one or this one. And remember, when 0 is not in the interval, there is a significant difference. Owen, you are correct. All right, how's that doing? We're feeling like we get it? Questions? Thumbs up when you wrote it all? Smiley faces when you wrote it all? That's good too. For the record, the 0 thing is going to show up in the chapter 11 flow charts. I have it right here. So it is going to be there. So I wrote, it's page 227 at the bottom, even though you haven't done that yet. That's the chapter 11 flow chart. It's also on page, hold on one second. We've written it like 3 times in this chapter. So 226, 226. So page 226 at the bottom. Oh, hold on. There you go. There. Okay. So now I'm going to let you guys do this page. Now these data are loaded in Canvas. Sorry, I just got to find it. So if I go to the 11.3 worksheet and I click on the data link, there it is. Why is this not saying I've signed in? You all saw me sign in. The heck? Who knows? All right, let me try that again. There, now it worked. Who knows? Okay, so the old curriculum's right there. The new curriculum's right next to it, right? Now, let's do a little review real quick. How do we find N, X bar, and S? Ooh, and what do those terms mean? All right, so X bar, I'm going to write it over here. X bar is, yes, thank you. All right, so let me make it note. So page 232, method 1. It's the summary stat columns. All right, X bar is what? When you have a bar on your head, it's the mean, right? So X bar is the mean. S is the standard deviation, right? What Owen just wrote. And then N is the size. Now the O's, these are O's for old curriculum. See it? See what I was doing? So these little guys right here are saying O, O, O for the old curriculum. And then these other ones are saying N, N, N for the new curriculum. See it? So you're going to have to run it. Now, oh, that's fine. No, I knew what you were doing. So the other thing is, let me just show you real quick. When you want to do this, stat summary, stat columns, you can say both columns at the same time. I'm just gonna do the median. This median wasn't asked. I just want you to see it. So when you do that, it'll find both of them simultaneously. Nice. All right. So just a little heads up, you can do it all in one shot. And then down here, you're going to verify requirements. You know what that means, random, independent, normal. So this is going to be random. You're going to have to squeeze them in here. Boop. And then independent samples, right, which is its own thing. Then independent of population. I'm just worried I didn't get enough space for independent samples. So independent of population. I will say this is one that you don't, you have to do independent of population twice. So you're going to have to do it for the old and for the new. And then normal. Normal, you can kind of say the same thing for both, but independent of population, that's the N is less than 0.05 capital N. You're going to have to do that twice. Normal, need the graph. I did an example on page 225. All right. And then we just showed how to do these two. This is page 226. This is page, I think, 225 and 226. I did an example on 226 in the instructions. So page 225 through 226. But we just did one. So I'm gonna let you guys do all that. All good? Thumbs up when you got it. Thanks, Emily. She is Johnny on the spot for their thumbs up today. She's like, I got it. All right. Next one. I gotta be honest, I really like the next one for exams. Hint, 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 hint. I like asking this kind of question on exams because everything's done and you're really interpreting what's going on here, which I like. Now, the first question. So if you read through it, it says a researcher for Nissan believes that cars made in Asia have different gas mileage than those made in Europe. They gather a random sample of cars from both regions, measure their gas mileage, and conduct the test. The test is done. You're not going to do it. You're not going to touch StatCrunch, right? So everything is done and the requirements are satisfied. It says, assume the requirements are satisfied, meaning don't check random, independent, normal, all that good stuff, right? So when you see this box, that means do not touch StatCrunch. It's done. It's already done. So I always have some students that are like trying to go to StatCrunch and rebuild it. I'm like, no, 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 no. You're just reading the output. Okay, so the first question for A is what kind of test is this? So it's either going to be a left-tailed test, a right-tailed test, or a two-tailed test. Anybody see it? Yeah, totally, Kendrick. Right? So everybody look, what determines that is your alternative hypothesis, right? So look at your alternative hypothesis. Look right here. Look. See that? Whoop. See the not equal to in there? See that? That's a two-tailed test, right? Because it's a not equal, right? A not equal test is a two-tailed test. And see how it has that not equal sign in there? That's how you can tell. All right, I'm going to let you guys do B and C and D. I think you guys will be fine. So that those B, C, D is kind of reading what's in there and kind of analyzing what's there. Don't forget to include units and decimal places and stuff. Right? Okay. I want to help you with E because sometimes students get confused. So we're trying to do just steps 4, 5, and 6 of the hypothesis test. Now, I always have some students that freak out and they actually want to do the whole thing. Like it bothers them that we're starting halfway through the hypothesis test. They're like, I want all the steps. I'm like, okay, fine. So if you want all the steps, it's fine. So step 1 would be HO mu1 equals mu2 and H1 would be mu1 not equal to mu2. Or you could write them as they were written here with the zeros. It's fine, right? Either way you want to write it. Right? Step 2 would be your alpha. So everybody tell me what your alpha is. Step 3 is your T0. See, 1, 2, 3, you don't need, right? If you want to write them because it freaks you out to not write all 6 steps because you're so used to writing all 6 steps, that's fine. But you don't need to. What you need to do is steps 4, 5, and 6. Although maybe I'll change that for future because so many students get so bothered by it. They're like, I want to write all the steps. Fine. So I was trying to cut back on your work here. All right, what's alpha? Do you guys see alpha yet? Yes, Emily, yes. 0.05. There it is, right there. So it's 0.05. Good job. Okay, so now what's the T0, everybody? Oh, and Kendrick too. Sorry about that, Kendrick. I didn't see you. All right, so what's the T0? It's in the output. Just look for it. What's the T-stat? Because that's what the test statistic is, right? Yes. Test statistic is T0. It's called T-stat in StatCrunch, right? So T0 is this guy right here. This is T0. So it's 3.746. And the p-value is 0.002, 0002. Now, Here's the part that's weird. You have to draw the picture without StatCrunch. So I know you guys are super used to relying on StatCrunch, but you have to know, like, I know what a two-tailed test looks like. It looks like that, right? And I know 3 point some standard deviations out is really far out. My tails are going to be smaller than what I've drawn here, right? Because, right, it's really teeny tiny. So let's say this right here is T0, which is 3.746. Now it's two-tailed, so I'm going to draw a companion over on the other side and call it negative T0, which is negative 3.746. And then I'm going to shade my tails. Now p-values for a two-tailed test get put up above with a double arrow. So that's what you're going to do. So the p-value goes up here. It's 0.00002, and it's both of those. So the important parts of this sucker are right here. Because that's your t-stat and your p-value. That's steps 3 and 4. Step 3, step 4. Right? Okay. So my p-value is 0.0002. So are we rejecting HO or not rejecting HO? Reject the HO because your p-value is low. So therefore, there is sufficient evidence to support the claim that, all right, now what was our claim? So we got to go back here and figure out what this was about. Cars made in Asia have a different gas mileage than cars made in Europe, right? It's up there, right? That's the claim. So that's what we'll say. So that cars made in Asia have different, right? Different because it's two-tailed gas mileage than cars made in Europe. Sorry, my page numbering there got in the way. Different gas mileage. Right, MPG. You could do MPG, right, for mileage if you want. Everybody good? Do you understand what to do now? Nobody's lost? So the first 3 steps were not technically required. What was required was the bottom bit, right? But you can do a picture even though you don't have StatCrunch doing the picture for you. You can still draw a picture. You have a sense of what that looks like. Or at least you should. Oh, thanks, Kendrick. Kendrick thumbed up. All right, everybody else thumbs up when you wrote it all. All right, I think I got everybody. All right, so then I'm not going to do this one so much, but I will help you with A, just to make sure everybody gets it. These are a group of students that have part-time jobs and another group of students that have full-time jobs. And this is the number of, what is it? How many times out they eat last week, right? So how many times out did you eat last week? So which one are you going to circle for A? Independent, dependent, quantitative, or qualitative? Are they one group measured twice, or are they two separate groups measured once? Yeah, they're two separate groups. It actually says the word separate right here. They are not one group measured twice. I mean, you could spot if they were, because if they were, there would be a difference row waiting for you to fill it in because it'd be paired. Paired ones are the ones that are dependent. So if it's paired, it's this one. If it's proportions, it's this one. This one we don't do. That's actually chapter 12. It's this one. Okay. I did an example like B in the notes on page 224, but you know what's coming. And then we're doing a test. So I'm just gonna let you guys do the test. You know what to do. So you're gonna have your HO and your H1. You're gonna have your alpha. Honestly, you could fit your T0 right here. Boom, because that's your T stat from StatCrunch. And then you're gonna draw your picture. And then you're gonna figure out what your p-value and your alpha compare, and then there is or is not blah, 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 right? We just did one, but that's just how hypothesis tests work. Oops, sorry, let me move that down. So there you go. All right, thumbs up when you wrote everything on the page, and make sure you circled the first one in letter A. Oh, as for an example of this kind, I don't know, maybe, I mean, I sort of did one on page 224. Same page. Just in terms of a test. I will say the one on the notes is two-tailed. This one is not two-tailed. This one's something else. It's one-tailed. Oops, I have 2 thumbs up so far. That's all right. Keep writing. Once you're done, go to page 554, because that's the cumulative review number 6 that we're going to look at. All right, I think I got everybody. Oh, and are you good? I can't remember if I saw your thumb. You're okay. All right, cool. All right, 554. Hey, regression. Old buddy, old pal. Yay. All right. Looks familiar, right? So it will be on the final. I guarantee you're going to have to do regression on the final. Now, in this particular case, I actually did the regression calculation. So you're really analyzing the output. So we went over this on, well, not over it, but it's page 233 in your yellow packet. Remember, page 233 is the page that is full of regression stuff, right? All the regression stuff is on this page. It's your buddy, okay? The one thing I will say is I'm still having people not write their equations right. Remember that when you do this, it's got to be y hat equals number. In this case, it's going to be minus number x. Like that is how it has to be. It has to have an x and a y and it equals. So don't just write one side of it, write the whole thing. Yeah, you guys know what to do. So we've done these a bajillion times. So don't forget to interpret down here. All right. I'm giving you a second. All right.
I have a
And then,
question on
oh,
that
go for
one.
it, Allie. Mhm.
So when we're like interpreting the slope or whatever,
Yeah.
it's that one slope that's like the average whatever increases by 1, we expect blah blah blah
Yeah.
blah.
Mm-hmm.
For the y units, it says percent. So for that number, do I put percent
Just say
after that
percent.
number?
Yes, just write the word percent or put a percent sign.
Okay.
Yeah. So in this case, percent sort of is your unit, right? It's the percent. See how it's got a little percent sign right there? Percent is the unit on that one. And this one's $1,000. So $1,000. So those are the units that you'll use. Is that okay, Allie? You good? Good question. Cool. All right. So, and by the way, this is real data if you're interested. This is the different states in America, and it's the percent of it's the average household income or average person income, and then it's the food insecurity rate. What percent of people don't have adequate food in that state? So it's kind of interesting. All right. So then this one. Okay, that was okay. In case, back. This is chapter 4, right? If you're wondering, like, where do I go? That's chapter 4. This whole page is chapter 4. This whole page is actually 6.1, right? Section 6.1. So this is on page 137. I'll tell you right now, there's 2 things you have to write. And then there's disjoint. Remember disjoint? Disjoint means you cannot have both at the same time. And not disjoint means you can have both at the same time. Nope, not disjoint. Stephen. Oh my God. My husband is making a joke about, you mean disjoint? As in this place? Disjoint. Get it? Can have both at the same time. You promised that when you were going to be in here working, you were going to mind your own beeswax. My Owen gave you a corny ear of corn as the reaction. That's appropriate, Owen. I appreciate that. I don't, now he's laughing out loud. Kendrick hasn't said anything. Kendrick, and Kendrick knows you. He knows your corny jokes. Because Kendrick had him, I think, for as a science teacher. All right, so these stuff like I'm just going to remind you, for some reason some people lost this in the exam and stuff, but like the probabilities are here. You use the table to answer the probability questions. Like I don't know how to say that more plainly, but I had some people just like making up numbers and I'm like, use the numbers that are up there. So you guys won't do that. All right, now this one, this is the trickiest bit. This is special. This is method 3 on page 232. It's the stat calculator's custom. Remember the custom calculator thing? Yep, it's a little review. It'll show up on the exam. Right? It's pretty common because it's an expected value calculation. So stat calculator's custom. It's right there. And then as for interpreting it, that's the script on the very first page of the yellow packet. It's the give or take script. Page 2. Kicking it old school. We've done this stuff a long time ago. So it's time to review. We've got 2 weeks before the final. Oops, sorry. Let me move that down. I'm just waiting for you to thumbs up me. Oh, okay. Tons of thumbs. Oops. Okay, now this bit, we just did this today. This is chapter 8. So, and somebody asked me, so for your note sheet, some pages to think about for putting on your note sheet would be pages 165 to 166 and then 170 because those are chapter 8. Right. Okay, so this one, I'm just going to say see page 166. There's a formula. Right, we just did one today, so I'm not worried about it. You guys can do it. And then this one, when you remember when you want to describe a population, you always begin with the word all. And then, okay, number 4. This was an actual exam question. Like I remember grading this exam question. You can tell because I left the points in there accidentally. So a lot of students got confused when they got this exam because they were like point estimate. Well, the point estimate is, hold on, let me grab page 189, the flow chart. They were like, oh, it's lower plus upper divided by 2, but they forgot about this piece. You can only use those formulas if you know the lower and the upper, which you don't, right? So page 189, you went lower plus upper divided by 2. No, 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 not enough info. You can't do that. You don't have the lower and the upper up here. But what you do have, and I don't think I put it on the, nope, I did. You have to look elsewhere. Instead of down here, where it says you can only use those if you know the lower and upper, you have to look back up here. And hopefully you wrote it well enough. See what I mean about writing everything I write? All of it, right? The point estimate is there. It's also in the yellow packet. So if you look in your yellow packet, if you look at the confidence interval, hold on. There, confidence intervals, look. Point estimate right there. It's p hat, which is x over n. So it's on page 237 in your yellow packet. It's also on page 189, right? Okay, so because this is for proportion. If it was for a mean, it would be x bar, right? But because it's a proportion, it's p hat, right? For p hat mean, right? Okay, so we would do p hat, which is x over n, and I'm gonna let you guys finish that. Right? But okay, now for C, using that point estimate, right? So this is the point estimate. So using that point estimate, but you need to figure out the minimum sample size. Oh, there it is. Okay, so look to page 190 for the formula. I expect to see a formula, a substitution. You did this on the project for chapter 9. You've done it several times. This is a sample size question. All right, and then I'm just going to remind y'all, this is from page 24. This is from chapter 1. There are 3 ways we can create bias. So there's response bias. So response bias was your questions were bad, your interviewer was bad, your people were lying, your answers were bad, right? Some stuff about the questions themselves, right? And how they were asked. That's response bias. Non-response bias is people won't respond. People will not fill out the survey. I have this every time. Every time I ask you guys, hey, where are you going to take your final exam? I always have like 5 people that won't fill it out. Drives me nuts. Right? That's non-response bias. They're not responding to me. I've got one in my Calc 2 class every time. It's like, tell me where you're taking your test. And then sampling bias is the sample is bad, right? The sample's not representing the population. Right? It leaves out, a group, or it's, it's only old people, or it's only young people, or whatever. You're trying to get a full representation. I can't write population. There we go. Just a little review of what those are. That was on page 24. Maybe something to think about putting on your note sheet, say, for the exam. All right, thumbs up when you wrote it all. That was legit an exam question, though. I wasn't kidding. All of these were. I think this whole thing is full of exam questions. Yep. It is. It's full of. Every single one of these was on a final exam at some point. All right, I saw some thumbs ups and hearts, so I think we're good. All right, critical Z values, that's page 236 at the top. When it's for proportions, so this is where people lose it. They're like, how do I know like which critical value that is, right? Well, you have to know proportions, P is proportions, right? If it's proportions, look at your confidence interval formula. Proportions, see that letter? The critical value is Z, right? So you are looking for Z alpha over 2 on that one. This is, oh Lord. Okay, so random, independent. This is a chapter 9 one, so this is more basic. There's not 2 groups on this one, there's just 1 group. Random, independent, normal. You've got a data set right here. I don't know if I actually put that data set in StatCrunch. This might be one that I let you do yourself because it's so easy. So let me see. Oh, I did. Let's see. I've got data sets. There you go. So they're right here. So there they are, all in their glory. So there's that one. And then you're going to use that to do the formula, substitution, all that good stuff. And then the result, right? This is on page 237, the bottom box. If you're looking for an example, oh boy, it'd be back in section 9.2. So it'd be a ways back. Let's see here. I did one on page 185. Nope. Hold on. Delay that. 181. 181. So if you're looking for an example, page 181. And I did this as well. If you're looking for an example, page 181 and page 182. Actually, 182 is better for that one. So if you need some old examples, and I'm just going to highlight this piece. More than 100. That's what you're looking at. All right. Ready to get to groups and start tackling the problems? All right, let me pause the recording. Goodbye, recording.